Assalamualaikum and good day. In this video, I'm going to explain to you the analysis of the root locus. This example, we have two poles and two zeros. The poles located at -1 and -2, whereas we have poles located on the right hand side of the S-plane, we have at 3 and 5. So when we draw the root locus will looks like this, where we have it starts from this location. Basically, we start from poles and end at zeros. So somehow it will cross the j omega axis. So what we can say about the stability of this root locus? So we can analyze starting from its locations, the starting point of the root locus, where we have at poles, where we have our k equals to 0, and at this point as well, k equals to 0. So whenever the k is on the real axis, what we have, actually we have k on the real axis. It has two poles and this different location. So we know that it is at this point, so I just call it as green over here. So we can say that this location, we have the system is over them, and zeta is greater than 1. And whenever we increase the value of k, the gain, we reach at one point. This is what we call it as breakaway point. And at this location, we have some finite value of k, and at this position we have multiple poles at the same location. So we know that at this point the response is critically damped, where we have our zeta equals to 1. And then as we increase the value of k, it will travels, one goes upwards, one goes downwards, and along this line. Okay, and it goes this one. And we know that when we have these poles located at this combination of real axis and j omega axis, we have these 2 points. We have under them response, where our zeta value is greater than 0, less than 1. And the system is stable at this moment from k equals to 0 until, let's say, at this point we have k equals to let's say we just give it a name kc. At this point as well, k equals to kc. Okay, so when we have k, our k less than kc, the system is stable because the poles lies on the left hand side of the S-plane. However, when the pole reach kc, when k equals to kc, we have the system at this location, we call it as marginally stable system, and our zeta value equals to 0. So at this position we have undamped response. So the oscillation will retain the same, neither decrease nor increase in its amplitude. And whenever the pole, when we increase the k past kc, what happens is it will cross to the right hand side of the S-plane. Okay, so it crosses to this location and to these locations. So we see that whenever k is greater than Kc, system is unstable. Okay, so we limit our discussion at this point. All right, so that's it we can say about this root locus. So if you have any comments, if you have any inquiries, please let me know in the comment on the YouTube, or you can contact me via WhatsApp and discuss with me as well in the class, in the lecture session.